Have you ever wondered how your smartphone knows exactly where you are, even when you're driving through a city you've never visited before? The answer is GPS, or the Global Positioning System. GPS is a navigation system that uses satellites orbiting Earth to determine the location of a receiver. It can tell your phone, car, smartwatch, or navigation device where you are, how fast you're moving, and even help calculate the best route to your destination. But how does it actually work? The GPS system depends on a network of satellites orbiting high above Earth. These satellites continuously send radio signals containing information about their position and the exact time the signal was transmitted. Your smartphone doesn't need to send a signal back to the satellites. Instead, it simply listens for signals coming from them. Here's where things get interesting. Radio signals travel extremely fast, at the speed of light. However, they still take a tiny amount of time to travel from a satellite to your device. Your GPS receiver compares the time the signal was sent with the time it was received. By calculating the difference, it can estimate how far away that satellite is. But knowing the distance from just one satellite isn't enough. Imagine you're told that you're exactly 20 kilometers from a particular location. You could be anywhere on a huge circle around that point. Now, imagine another satellite gives you another distance. The possible locations become much more limited. With signals from 3 satellites, a receiver can narrow down its position in 3 dimensions. But GPS normally uses at least 4 satellites to determine your exact position and correct for a very important problem. The clock inside your phone isn't nearly as accurate as the atomic clocks on the satellites. The 4th satellite allows the system to correct this timing error. This process is called trilateration. And here's an important detail. GPS satellites carry extremely precise atomic clocks. Their timing must be incredibly accurate because even a tiny error in measuring the signal's travel time can produce a significant error in the calculated position. GPS also has to deal with something predicted by Einstein's theory of relativity. Because satellites move at high speeds and experience a slightly different gravitational environment than objects on Earth's surface, their clocks tick at a slightly different rate. Engineers have to account for these relativistic effects, otherwise GPS positions would quickly become inaccurate. Once your device calculates its position, software can combine that information with digital maps. That's how your phone can show a blue, moving along a road, calculate your speed, estimate your arrival time, and provide turn-by-turn directions. But GPS isn't only used for navigation. It is also essential for aviation, shipping, emergency services, agriculture, surveying, telecommunications, financial systems, and scientific research. Even systems that don't seem related to navigation can depend on GPS because extremely accurate time synchronization is valuable in many industries. And GPS isn't the only satellite navigation system in the world. Other systems include Europe's Galileo, Russia's GLONASS, and China's BeiDou. Modern smartphones can often use signals from multiple systems to improve positioning. So the next time your phone tells you exactly where you are, remember what's happening behind that simple blue. Satellites are sending precisely timed signals across thousands of kilometers of space. Your device measures those signals, calculates distances, corrects for timing effects, and uses mathematics to determine your location. All of this happens in just a few seconds. GPS is essentially a giant space-based timing and measurement system that turns signals from satellites into a precise location on Earth. And that's how your phone always seems to know exactly where you are.